Hello. In this video, I'm going to go over some strategies for memorizing the multiplication facts. So we want to internalize the facts and later on be able to recall them instantly. Okay, so it's important to be able to do this because in this course, you have to be able to multiply quickly to do some problems. Even things like long division require multiplication. So if you're going to do well in long division, you have to understand and recall the multiplication facts. Also, for Math 50, the multiplication table is so important that I would say if you don't know it, it's a good chance, very good chance, you will not pass the course. I've seen this firsthand. So the quicker you know the tables and you're able to recall them during a problem, the more swiftly you'll be able to finish a problem. And the reason is that for a lot of the problems in Math 50, they're multi-step problems. And knowing multiplication is only one part of the step. You don't want to get hung up on that one part of the step because you have several steps to do, not just multiplication. So you cannot let that be the stopping point for you. All right, so what I'll do here is I'll go over some strategies and I'll begin with some properties of multiplication to help you understand a little background about it. So one way you can think about multiplication is that it's repeated addition. So the multiplication table that you're probably familiar with is really nothing more than the answer being shown in a cell to some question. And the question is, what is the answer when I have 4 groups of 3? What is the answer? And the answer is 12. Now, when you say 4 groups of 3, what are you talking about? Well, you can think of it this way. So pretend you have 1, 2, 3 boxes here, 1, 2, 3 here. You have 4 groups of 3 boxes. So you can think of this as there are 3 boxes here, plus another 3 here, plus another 3 here, plus another 3 here. So altogether, there are 4 groups of 3. So 4 times the 3 is 12. So it's really adding the same number repeatedly. Multiplication is repeated addition. You can think of it that way. All right, so let's keep going here and look at another property, which is called the commutative property. So the commutative property says that you can change the order of the numbers being multiplied and it's not going to affect your answer. 3 times 4, 4 times 3, the answer is 12. So here in this first example, example 1, we have this 3 represents the rows, 1, 2, 3. This 4 represents the columns, 1, 2, 3, 4. When you multiply that, you have 3 rows by 4 columns. Well, 3 times 4 is 12. You can say that 3 groups of 4 equals 12. Okay. So the commutative property says you can change the order here. You can swap the 3 and the 4, like we did down here in part 2. In part 2, the 4 represents the rows, 1, 2, 3, 4. The 3 represents the columns, 1, 2, 3. So here we're saying, how many boxes do we have? How many rectangles? When we have a 4 by 3 grid, well, you're going to multiply 4 times 3, and you know what? You still get 12. See that? So these two are the same. Down here, we can say that there are 4 groups of 3, and that still gives us 12. So the commutative property, in essence, says that you can change the order of the numbers being multiplied and still have the same answer. So this is going to be important when you're looking at the multiplication table, because what this infers is that you don't need to memorize the whole table, but only half of it. since 3 times 4 is the same as 4 times 3, there'll be a diagonal. You'll see a diagonal, which will cut that multiplication grid in half. And that's due to this thing called the commutative property. All right, so let's look at one more thing, associative property for multiplication. So here, when we say associative, what that really means is that we're grouping. Okay, think when you hear the word associative, think grouping or using parentheses. So here what we have is 1, 2, 3, 4, 5, 6. We have 6 boxes with a number 4 in it. So if we group in number 1 here, if we group these in such a way where we're using 2 boxes here, we're grouping the 2 4s over here, and then we're grouping the remaining 4s, the 4 4s here. And then if we multiply that, we get what? 4 times 2 is 8, right? And then here we get 4 times 4, which is 16. So out of this little group here, we get 8. Out of this group here, we get 16. And that's listed right here. If we add those, we get 24. We get 24. So 6 times 4, or 4 times 6, is 24. When you group it this way. But what happens if you try grouping it a different way? Let's say we group these 6 boxes by 3s. There are 3 groups here, 3 groups here. So here we have 3 groups and another 3 groups here. All right, well, let's see what happens. So we have the number 4 times 3 boxes, and that gives us 12. And that gives us 12. So the number is 12 here. And then we have 4 times 3 boxes, and again, it's the same number, so we have another 12. Another 12 here. So we have the number 12 here and the number 12 here, which is listed down here. You add them up, and you get 24. So see, it doesn't matter how you group these. It's called the associative property, and you still get the same answer when you multiply. Okay, so actually, let me just do a quick side problem here and show you. So let's do this. 1 times 2 times 3. And let's say I want to group it this way. So here we have 1 times 2 is 2. Bring down your 3. 2 times 3 is 6. 6. All right, well, let's try the same thing, but grouping it differently. Instead, I want to group these 2 here. Okay, so whatever's inside the parenthesis, you have to do that first. So 2 times 3 is 6. Bring down your 1. And 1 times 6 is 6. See that? They're the same. So the order does not matter in multiplication. So again, or the grouping, sorry, the grouping does not matter in multiplication. So this is a nice concept to know for later on. All right, so why don't we move on to and look at some of the tables here. Okay, so let's start with something that's called the list format. Okay, this is called a multiplication in a list form. In a list form. So this might be a good place to start. If you're struggling with multiplication, this might be a good place to begin your multiplication. So all you do here is you just fill out the table as you go down the lists. So 1 times 2 is 2, 1 times 3 is 3, keep going. Then you come over here, then you come over here, the 4s. Let's do a couple of these. 2 times 7 is 14. I don't have enough space here, so I gotta skip a few. 7 times 4 is 28. 7 times 8 is 56. And so on and so on. Now you'll notice that these numbers are going to get higher, right? By the same amount, since we're multiplying by 7 here, as an example, this number is going to go up by 7 each time. Now here I couldn't squeeze in that 21 because it's too small. 14, 21, 28, 35, 42, 49, 56, 63, and so on. So this multiplication list format might be a good way to begin your training into internalizing the multiplication table. And also, here's what it would look like if I had it filled in. Oops, where'd it go? Oops, right here. If it was filled in, it would look like this. Notice how these numbers go up. Let's take the number 3, for example. The numbers go up by 3, 3, 6, 9, 12, 15, 18, 21, and so on. So here you can see the built-in repeated addition, right? Let's take the number 6. 6 plus 6, 12, plus 6, 18, plus 6, 24, plus 6, 30, plus 6, 36, plus 6, 42, and so on. So there are patterns to these multiplication tables. So begin with a list format. That's what this table is called. It's called a list format. Let's move on to another format that's called skip counting, which is somewhat similar to this. So with skip counting, what happens is that you're going to take a number. So let's take the number 8, for example. Take the number 8. So this says we're going to count by 8s, and we're going to take multiples of 8 going this way, going this, and you'll see that you'll see this on the blank version coming up next. But this table is already filled in to show you the pattern. So this is multiple number 1 here. In other words, 1 8 is 8. 2 8s is 16. 3 8s is 24. Another 8 is 32. Another 8 is 40, 48, 56, 64, 72, 88, 96, all the way up to 12 8s. This here, what you see, is very similar to a multiplication table. In fact, I created this from a multiplication table that I have. It's very similar, but it focuses on the skip counting part, which is repeated addition. Okay, so this goes left to right, not up and down, left to right. Let's take the number 11. 11, 22, 33, 44, 55, 66, 77, 78, 88, 99. As you can see, patterns show up, right? Patterns show up. So when you multiply by 11, whatever multiple it is going to be that number. 11 6s are 66. So there are definitely hidden and unhidden patterns in multiplication tables that will help you to internalize this. So here's what a blank one will look like. Okay, right here. Here's what a blank one looks like. So let's try one and see what happens. Okay, let's try the number 4. All right. So here we have, let's try the number 4. We're going to count by 4. Now the first multiple is given. The first multiple is given. The second multiple is given so you can see the pattern, right? So you know what to do. So we're going to keep adding by 4. We're going to take multiples of 4. So here we go. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. Okay, 48. So use this skip counting table to help you understand the multiples of a number. Okay. All right, so let's look at the table which you're probably very familiar with. And that's this table, the multiplication table. Now look, this looks very similar to the skip counting table, right? Very similar. What I did was I chopped off this top row, pretty much. Okay, now, so this is the gold standard here for internalizing the tables. This is it. Still use the other two to help you get here, but this is where you want to be. So what this table here does is that, first of all, the arrangement. All right, so we have numbers listed along the left, numbers along the right. So let's say you want to know what 8 times 9 is. Well, let's take 8 here. Here's our 8. Take one number, circle it up here. Take the other number, circle it down here. And wherever they meet is our answer. 72 is our answer. So 8 times 9 is 72, right? 72, so remember that. Well, what happens if I want to know what 9 times 8 is? Let's see what we get. So 9 times 8. What is our answer for 9 times 8? It's wherever they meet. Well, look at that. It's also 72. That is because of the commutative property. So thanks to the commutative property, 9 times 8 is the same as 8 times 9. Notice this long diagonal down here. That separates the multiplication table in 2 pieces. That side and that side. All you really got to know is one or the other side right there. That's all you really got to know. Because whatever you have here, it's the same thing here. 3 times 4 or 4 times 3, it doesn't matter. It's the same result. Okay, so there it is. There it is right there. So spend time with this table to really get to know some of these facts. So that's a filled in table. And then over here we have a blank table. So here we have a blank table, and there are different strategies on how to fill this in. In fact, let's look next here on our list of what we need to cover in this video. So, how to internalize the multiplication facts. Now notice that there's no zeros here. And the reason is that 0 times anything is 0. So 0 times anything is just 0. In fact, let's say we had this problem. 2 times 0 times 5. What is the answer here? Okay, well, we said that 2 times 0 is 0, so 0 times anything is 0. And then you have 0 times 5. Well, again, 0 times anything is still 0. So if you have a string of multiplications going on and one of them is 0, the whole answer is 0. So that's why I didn't put 0 here, because it's pretty self-explanatory. And in fact, the number 1 also is fairly self-explanatory, because 1 times any number is that number. Okay, so 1 times 5 is 5, 1 times 9 is 9, and so on. It is on the table here because most tables have them, but so 0 and 1 are pretty straightforward. All right, now some people recommend to start with the so-called easy numbers. Now, they might not be easy for you, but they're easier, I suppose, than some other numbers. And that is the 2, 5, 10, and 11. So let's do a couple of these so you can see the pattern. So we can either do, when we do 2, we can either go down or go across. It doesn't matter. I'll just go across. So here's how we read this. You can think of it as a big times here, times. Okay. So 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. You could do it this way, which I would recommend, because then doing it this way solidifies the path of multiplication. Or you could do it as 2, 4, 6, 8, but that's kind of almost, I would do this 2, 4, 6, 8 thing earlier using the list method or the multiples, the skip counting method. At this point, you want to internalize the multiplication aspect. So don't just say 2, 4, 6, 8, because you're not really thinking about, well, what times 2 is 8? Do you really know that it's 4? Or are you just saying 2, 4, 6, 8 because it follows a pattern? So when you're filling the table in, I would recommend you actually think about the multiplication. 2 times 7 is 14. That way, that gets hardwired into your brain. 2 times 8 is 16, and so on. So start with 2s, then maybe try the 5s. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. Now notice with the 5s, the ending number, the rightmost digits, ends in 5 or 0, 5 or 0, 5 or 0. So that's one pattern that can perhaps help you. Let's try the 10 next. 10 times 1, 10. 10 times 2, 20. 10 times 3, 30. 10 times 4, 40. 10 times 10, 100, and so on. So 10 times whatever number is that number with a 0 at the end. Okay, not too bad. The 11s. Okay, so the 11s aren't actually that bad either. The 11s, you got this. So you have 11 times 1 is 11. 11 times 2 is 22. 11 times 3 is 33. 11 times 4 is 44. All the way up to 11 times 11 is 121, not 111. Okay, so 121. So the 11s from 1 to 9, which is 11 times 9 is 99, are fairly easy. The couple of hiccups are 11 times 10. Whoops, sorry, put that in the wrong spot. So here. 11 times 10, 11 times 11, 11 times 12. It's somewhat a little bit more difficult, but more or less, though, the 11s are pretty straightforward. Okay, so we have that checked off. Why don't we try some of the 3s and 4s? Let's do the 3s first. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Keep going. Then we do the 4s. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. Keep going. Okay, that takes care of the 3s and 4s. Then learn the 9s. The 9s. All right, so the 9. 9 times 1 is 9. 9 times 2, 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. 9 times 6 is 54. 9 times 7, 63. 9 times 8, 72. 9 times 9, 81. On and on and on. Now, some interesting properties about the number 9. Notice that the sum of each box equals 9. 9, there's 9. 1 and 8 is 9. 2 and 7 is 9. 3 and 6 is 9. 4 and 5 is 9. 5 and 4 is 9. 6 and 3 is 9. This is an interesting property of 9. There's also a pattern here. 1, 2, 3, 4, 5, 6, 7, 8. Whereas if you look at the other number, the right-hand digit, 9, 8, 7, 6, 5, 4, there are definitely patterns. This is one of those hidden patterns, and I'm not saying you should know it, but sometimes it helps to understand these little nuances of these numbers. Okay, so we did 9. Let's try 6, 7, and 8. Okay, number 6. 6 times 6 is 6 times 1 is 6. 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6, and so on. And we have 7. 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5, 7 times 6, 7 times 7, and so on. When I was in school, grade school, I suppose, 7 was one of the easiest ones for me. And you want to know why? Because I like football. That's why. And football comes in touchdowns. And touchdown is equal to 7 points. So for me, the 7s were a piece of cake. So you can use those kind of things to help you, right? If you're into football, fine. If not, that's okay. You can still learn the 7s. So you can use real life experiences to help you connect with the facts for certain digits. Okay, and then let's move on to the 8. 1 times 8 is 8. 8 times 2, 8 times 3, 8 times 4, 32, all the way to 8 times 8, and so on. Well, look, we're down to the 12s. I would say the 12s probably is the hardest one. Probably the hardest one. All right, so for the number 12 here, let's start. 1 times 12 is 12. 2 times 12. 3 times 12. 4 times 12. 5 times 12. 6 times 12. 7 times 12. 8 times 12. 9 times 12. 10 times 12. 11 times 12. 12 times 12. It goes up by 12s. So it'll take you a little time to get used to this, but it definitely could be done. Now, guess what? We're done. So there it is. We pretty much filled in the table just by talking about it. So use this pattern down here, the sequence that I've seen recommended on the web. And I think it kind of makes sense. So use that as a way to help you to really focus on the numbers you need to know. All right. Something else I want to show you down here. Let's go with 1 times 1 is 1. Let's put that here. Now, if you go down here on this diagonal gray line, notice that these are called perfect squares. You don't need to know that in Math 25, but you will in 50, I believe. You may need to know that. Or 128 or anything bigger, you'll have to know perfect squares. All a perfect square is a number, is the answer to the question, if you multiply the same number by itself, what is the answer? And the answer is it's a perfect square. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. And so on, right down the diagonal. Okay, so just, that's the reason why that diagonal is highlighted there, is to show you that these are the perfect squares, 1. And 2 is that either side of this diagonal is symmetrical, pretty much, because of the commutative property. All right, so let's keep going here, and let's see what else we have. So I think I covered all the images I want to go over. So let's talk about the drills. What I would recommend is to start with the list format, right? The list that goes right down the list. Start with the list format. Which is this thing here. Start with the list format. You know, nail that, really understand it. And then move on to the skip counting method. Skip counting, which is this thing here, skip count. And you go straight across, left to right. Count up in multiples of that same number. 8, 16, 24, 32, and so on. All right, and then finally, master the grid format. I call this the grid format because it is like a grid. Oh yeah, and something else that I used to do when I was learning the tables, there were always a few numbers that for some reason I just had a hard time memorizing. And I recall that 9 times 6 or 6 times 9 was one of them for some reason. Even here, I stumbled a little bit on it. So here we are. 9 times 6 is 54. Well, let's pull up this way. 9 times 6 is also 54, right here, 54. So one technique you can use, that I use, which actually was very helpful, is that for the numbers that gave you trouble on your grid, you know, you're going to print this out and fill it in, highlight that box. Highlight that box right there. So whichever numbers give you issues, highlight the box. And then the other ones that you're okay with, don't highlight them, just leave them written in with your pencil. So that way, when you're looking at this table and studying on the table, you can zoom in on the highlighted cells that give you trouble. Okay, so that way you can internalize them even more. So that's one little tip there that I can give you on how to create a table and help you to really work on the problem facts. Okay. All right, so we got that. Okay, now I have some drill sheets on my website. If you go under the MATO 25 webpage, I won't be able to pull it up here, will I? Let's see. Let's see if it comes up here. And I'm hoping you can see this, but this is the MATO 25 webpage and the section on multiplying single digit numbers. So if you go down a little bit, you'll see these worksheets. And if you click one of these, hopefully you can see this, you can use these as additional ways to drill. And you have answers down here, by the way. Okay, so here we're focusing on the number 6, as you can see, right? We're focusing on 6. And notice that we're using the commutative property. In some cases, we're saying 1 times 6, then we're saying 6 times 12. So we're flip-flopping the 6 and the 12. All right, so use those. Let me close out of here. Use those drills to help you. Now, something else you can also do is try some phone apps. Now, I'm not familiar with any, but I know they exist. Just do a search on web apps, okay? Free phone multiplication facts apps, and you'll certainly come up with some. So use those, because I think they could be handy since you always have your phone, except when you're in class, right? Okay. All right. What else? So as far as the schedule of how you should study these things, I would recommend to do it daily, right? Do it daily. Don't skip a day. 10 to 15 minutes each session, 3 times a day, morning, midday, evening. So don't do it for too long. 10 to 15 minutes in chunks. Do it in chunks. Morning, sometime in the middle of the day, and then in the evening. And you'll see it's gonna snowball. Initially, it might be hard. Then it's gonna get better and better and better, and then it's just gonna snowball. Next thing you know is you'll be able to fill in this whole table with little effort. And that's what you want to aim for. All right, so to summarize here, you can think of the multiplication facts as shorthand summary of numbers that were already multiplied and answered for you. That's how I see these. So let's take the number 45 here. Let's take the number 45. This is an answer to some question. And the question is, what is 9 times 5? And the answer is 45. The answers are right on the page. They're looking right at you. So there's no computation to be done here. It's simply a matter of linking the question to the answer. The question is, what times what is 24? And the answer is 8 times 3 is 24. So you see that? So when I do the facts and somebody says, you know, what's 9 times 8? And I say 72. I did not sit there in my head and repeatedly add a bunch of numbers. Nope, that didn't happen. I didn't multiply in some super fast way. I think of it as more like a label. I attach to the question 9 times 8 or 8 times 9. I see in my mind, when I ask that question, in my mind, I see the number 72 clearly as I see it right on the chart right here. So it's an association, right? I'm associating 9 times 8 with 72. So I think that's the level you want to get to. You don't want to keep skip counting, because it'll get you there, but it's the long way. It's going to fatigue your mind. You're going to have multi-step problems, and multiplication is going to be one part of it. You don't want to be there stuck with doing step counting to find out what 9 times 8 is when you have 3 or 4 more other things to do for that problem alone. Never mind more problems. So the quicker you become at this, the better it is. So I think of these as labels, as I said. Now, I have some examples down here. So for example, as far as thinking about labels, if somebody asked you, what is your address, right? Your address, the number part of your address. Obviously, you're not going to add or subtract anything here or do any kind of step counting, but all of a sudden, those digits come into your mind. You have a label. your house and those digits and the address go together. Zip code, how about your zip code? Same thing. The numbers just pop in your head because you have an association, those numbers, your zip code, with the place where you live. Phone number, another thing, phone number of your friend. All of a sudden it's in your head or it's on your phone. But back in the day, it was in your head. So those are some of the examples that where you can think of this as these are labels to a question that's being asked. So it's a little aside there. So my recommendation is for you to strive and achieve first accurate, then quick multiplication facts recall. Okay, so first accurate, no doubt about it, then quick. Not quick first and accurate. Accurate has to be number one. First accurate, then quick. What else? So I have all these multiplication facts tables on my website, and you can download all these. Go into my webpage again. You'll see them there. Print them out, and then fill them in. So hopefully this video is going to help you with multiplication facts. Very important topic for this and future math courses for you. So if you like my content, click on the like button, post your comments, and subscribe to my channel. Thank you for watching.